What's up? Josh from Rhino Lights. Kind of want to discuss our new rock light we're trying to do. I've been getting some question about kind of what's the difference between RGB and kind of our current RGB rock light and what we're trying to do with this new RGBW. So I kind of want to discuss what we're trying to do, the challenges we're having, and kind of the misleading information that's out there from a lot of these other importers that make bold claims, but they really have nothing to back it up. So I kind of want to go over some of that now. So let's dive in. All right, so as we currently know, this is our current RGB rock light. As you see, there's 24 LEDs. And the big thing I try to express to people is just because it has more LEDs doesn't mean it's brighter. So while we have chosen the brightest RGB chips that we can find on the market, that if you get a single color chip, kind of like in our Diamond Duos, just because of the quality of those can be much brighter. And so let me show you kind of our purple. So in these diodes, these are 12 volt, and all these do is like a red and or red and blue, where inside these diodes you have a driver, you have 3 diodes to control them. So there's a lot more stuff in the same amount of space, where the whole chip does one color. So that's something to remember when you're looking at these diodes. The quality of diode is going to dictate how much power goes into it and how that's converted to lumens, light output. You know, because you create heat and then you create light. And so the higher the quality of the LED, the more it can take that power and turn it to light versus it getting wasted with heat. So that's something to kind of keep an eye on. And so while these are 2 colors, super bright 2 colors, one of each side, and these are really big for the animations. You see the arrow, you have animations, you have patterns, you can interrupt it, they're addressable. And so what we wanted to do with our RGBW chip is kind of do that same concept. And so kind of the tradition of these that are on the market, they are RGBWs, but they're analog. So what that means is they have power running to each one of these diodes. So in each of these diodes, there's 4, or each of these LEDs, there's 4 mini diodes. And the traditional way to turn these on and off is you run a small wire to them and you just change the voltage that goes to those diodes and kind of make color. Well, I wanted to do a little different because I like the digital system that we have here. And so with this digital system, it allows us to interrupt it, do turn signal, do break, you know, do addressable patterns you see. And that's what we wanted to do here. We want to keep the same concept where you have power, ground, and then a data signal. And that data signal, we can make these addressable and interrupt them. And then in this one, there's 6 pixels. Every column's a pixel to kind of get that pattern. Well, what we ran into here is the power of these Cree LEDs. These things are monstrous. This, what you're looking at with those 6 diodes, is about a 43 watt light. If every single one of these diodes are on in these LEDs, this thing is pulling over 10 amps to give it max power. It's just insane the amount of power these diodes take. So that was a challenge we ran into. What we're trying to do is also do this daisy chain effect, where you can have a signal come in, go through the light, and then come out and potentially go to the next light. And then that's how the animation would work. So it takes 6 of these to equal 1 of these in the sense of the pattern. Now, what we're realizing and noticing is how strong these LEDs are. These Crees are just demolishing the brightness of these. But what you get with this is you get the full animation pattern in each of the lights. So that's the cool factor of that. And so furthermore, what we ran into with this guy is because of the power this thing's consuming, it's just too much. It's too much power going in this. This housing just isn't enough. It gets too hot and it's pulling too much power through this wire. So in our next iteration, as you see, it looks, you know, much different. But in our next iteration, we drop down to these 4 LEDs. Same kind of LEDs, but we're dropping down to 4. And in doing that, it helped reduce the heat because this was unstable. When this ramped up with all these LEDs, this thing got scorching hot and started messing up some of the other components in this board. And so when me and the engineer sat down, we said, all right, let's reduce the number of LEDs and let's try it now. And so now that we've reduced the LEDs in this, this is actually starting to work, where we can actually see the animations and power go through. So let me show you. So I have a demo set up, same controller, goes through, goes in the first one. And so you'll go 1, 2, 3, 4, and 5 is kind of what I hooked up here. Now what we're trying to decide and figure out is how many of these suckers can we daisy chain together before it's just too much for this wire. And so when I turn this on, and besides it blinding me, well, it's on red right now. Let me get the app and I will change it. Give me 1 second. All right, I'm back. All right, so for the purpose of this video, so I'll max this thing out. Well, that's the speed. And you can just see it's so blinding. So I'm gonna dim this down so we can kind of see what's going on. And so this is the same app we use. And as you see, you can see the pattern going. And so this is 5 pixels where this is 6. But you can see how the pattern is kind of going do, 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 do. And so what this leads us to do is you can run, say, this into the first wheel well, potentially put 2 lights, excuse me, run down into the belly, maybe put 1, and then go back to the real wheel well and do 1. Or, depending on how crazy you want to get, you could run 1 to the wheel well and then do 2 or 3 lights in that single wheel well, and then run another wire from the controller to your rear wheel well, and kind of have the animation going like that into your wheel. But the big thing that you're getting out of this is the digital system. And so treating each one of these as a pixel in the line allows us to do a lot of these animations. So if I turn it on to music mode, you can see how it reacts to the sound of my voice. You don't get that with the current RGBW stuff on the market. So that's the cool thing about this. The next step for me is to take it to the Connects board and doing the turn signals off of these. And so then you can actually initiate turn signal, brake, reverse, and have an RGBW system that does that kind of stuff. And so while these have been amazing, super bright, been awesome with the animations, trying to see what we can do to kind of mix it up on the next iteration, you know, knowing what we know now. And so the 4 has been great so far, but these things they're just so bright. They're just so deathly blinding. And the cost of these actual LEDs are just insane. And so trying to help balance the cost with the brightness, I think you're not going to tell really a difference between 3 and 4 at all. It's going to be so minute, you're not going to be able to tell, because what it's going to do is reduce power consumption and reduce heat. So it's going to take it from the 6 that we started with down to 3, which will still be about a 20 watt rock light each. So it's 20 watts is still an enormous amount of power to dissipate in these little housings. And so yeah, that's kind of our journey right now with these things. Testing has been going great. You can see a lot of the animations and patterns come through, which is really cool to see. So yeah, it's been a lot of fun to kind of figure this out and see how we can do this. So let me know if you have any questions. Like, I'm really excited about these. You know, I think these are just gonna change kind of the rock light game for better, just pushing limits and forcing people to kind of think outside the box with lighting. So yeah, that's kind of what I have to say about our new iteration of our RGBWs. You know, I'm trying to think outside the box and really push the limits, since we're developing this stuff, and, you know, pushing what's out there and really see if we can mix it up and do something unique. You know, not many places can say that. Not many places can sit there and hold prototypes in our hands and show you what we're doing, unfortunately, because a lot of places just order from overseas and say they're innovating. So yeah, let me know if you got any questions. I'm hoping we'll have the newer version in about another week. We made the changes to the board. We'll place the orders for the fab shop to actually make the raw PCB boards, because, you know, we do make our own boards. So you know, we're making our new boards, putting the parts on them, and we'll kind of get the housings updated and see how those do, and then maybe we'll have some prototypes out that we're ready to start selling. So let me know if you guys have any questions. I've appreciated it, and you'll have a great day.